Any of the first years are here to get credit. There's 2 phones at the back. Tap your ID so you can take what you need. Brenda's pointing at them. You've done it during attendance on the PM and in the morning, so you guys should know how it works.
Yes, you have to be here. We did it. Okay, good afternoon, everyone. Welcome, first years and second years. But like I think Chris was saying, this is kind of returning more back to normal than ever. We're actually giving presentations in the RPIS. Matt, so I think for a lot of you, unless you were a TA, this will be the first time you've given a presentation up here in the RPIS. We'll keep that in mind. We've got 4 presentations to go. For producers, keep an eye on me. I keep track. I have these signs I will pull up. I also have a clock that will be running, so you can kind of keep track of time. You also have the confidence monitor. You've been up there, so that'll help you sort of keep track of time. I'll hit you with the stop. You better start wrapping it up then. Then we have 5 minutes Q&A. We'll help sort of like faculty have first dibs, but any students can ask as well. Do we have any clients in the room? Yeah. Okay. So it's Halves. You're supposed to sort of give us a sense of what you've been doing, what you're up to this past semester, and your plans moving forward for the rest of the semester. So without further ado, we have 4 productions up already. Impression next after that, and then Molten Core, and then we'll end with Ideal. So, 404, take it away.
Good afternoon, everyone. We have 404 Productions. This is our team. These are our instructors. We are making a mini-game compilation abstracting basic cybersecurity concepts. So as an introduction, we are working with Carnegie Mellon University Scilab, who holds an annual cybersecurity competition called Pico CTF, and we are making a game for that. And I'll pass it on to Oscar, who will talk through our video.
Yeah, so I will show a quick video of some of the work that we've done so far, and don't worry if you don't understand. We'll get into details later. So play again the big map, and get into one of the mini games that we made. And the goal of this game is to escape. And there's a lock here. Some pop-up text got out. The player is trying to input some random stuff. No, it's not going to work. And he need to figure out something. So he's trying to randomly search some books, I guess. Now the pop-up text kind of give it some hint. A lot of weird code. What is that? So an obvious book. Okay, I guess the player can get some hint of how to convert the weird numbers. Okay, let's go next. Find a piece of paper. He's trying to decode that, I guess. You may need that. Yeah, that's what I thought. Okay, I think now he knows what's the next step. Goes to the fireplace. He did some trick. Whoa, it worked. And then another code pop-ups. So yeah, that's generally how this game works. The player will just keep decoding and eventually get out of the room. But because of the time limit, we don't have time to go over the whole video, so I'll just stop here and pass it back to Louis.
Thank you, Oscar. So some of you may already be familiar with Pico CTF because all of these were past EDC projects that were done for Pico CTF. But we are different this year. So the people who are familiar will be familiar with the main Pico CTF game. But this year, they're splitting it into 2 competitions. There's still the main game, but there's a mini game first. So the mini game is a smaller competition. There's less questions. There's only 14 questions, and we know all of them. It's aimed at beginners. Is a lot easier. And that's where we will be putting our game in. So as I said, we know all the questions. Some previous teams didn't know all of the questions, so their games were a bit more generic. Ours, we know the questions so we can actually convey concepts for cybersecurity through our game that will help them specifically for this competition. And our final goal is to encourage players to try the competition questions and answer all the questions. It's achievable because there's only 14. And because our client is Scilabs, they want people to play the Pico CTF game and complete the questions. So we are not including the Pico CTF questions directly in our game, it made it a bit inflexible for us to design around it. We felt it was easier to convey concepts by explaining them in our own way. And once they understand the concepts, then they can tackle the questions themselves. Our target demographic is high school students who have little to no cybersecurity. If they had cybersecurity or programming knowledge, then they wouldn't need our help. And they might not be interested in cybersecurity in the first place, because Pico CTF is known as a beginner-friendly game. So there's lots of people who would take this as their first opportunity to delve into cybersecurity, or some teachers might ask their students to sign up for this competition, so they wouldn't have any interest in the first place. Our final deliverable is a Unity WebGL game inside the Pico CTF website. Here's the example of the 2019 Pico CTF game, so it'll look something similar to this. So now I'll talk a little bit about the game design. We're making 4 mini-games and 1 game wrapper around it. The 4 mini-games will each cover different cybersecurity concepts, which will hopefully teach or convey concepts that a player will be useful for the Pico CTF questions. For the setting, we're making a mix of science and fantasy, a bit like steampunk, and players will be students in this cyber magical school. They can freely explore around the school and try out different activities, which would be the mini-games that we have, which teach concepts. And players will be earning points for their houses or teams, and then they'll compete in that way in our game. And I'll pass on to Jizup, who will talk about the metagame and game wrapper.
Thank you, Luis. First, I'm going to talk about the game flow first. In the intro scene, the users will select the house and move on to the map and the mini games. And center of the presentation is our core game loop. In the mini games, they learn the basic knowledge of the Pico CTF challenge questions, and they will learn by playing. In the office hours, they learn the concepts handled in the prior mini game. So they can read materials, but reading materials are not that long, but it reveals the secret of the game. They will learn by studying. And the last thing is bulletin board. In the bulletin board, they can check the scores and they can see their contribution to the team and get motivation. We'll provide the links to the real mini competition challenges. So I'm going to talk about the details. Before start, except for the mini games, everything is under bit development, so these screenshots are from the minimum viable product of the game without any art assets. So they can get the sequence of questions, and according to the answers, they'll get the team based on their answers. On the map, users can move around the room, and they can move to other places. As the game progresses, the users will unlock the new stages. In the office hours, they can learn the knowledge related to the prior minigame. For instance, users can learn the ASCII after the first minigame. While playing the minigame, they didn't know they used the ASCII conversion, but in this place, they can reveal the secret of the knowledge they used. And the last element is bulletin board. They can see their team scores, and it motivates the users to compete and contribute to the team. And we'll provide the links to the mini Pico CTF competition, so users will get familiar with the Pico CTF competition. They'll find out that the questions are not that hard because they know everything to solve the problem. And now I hand it to Oscar.
All right, thank you, Jisoo. So next, I'll be going over our first minigame idea, which is the escape room, which is what you see in the previous video. So in this game, player will basically explore and interact with the environment, find evidence, and eventually get out of the room. So one concept we're embedded in this game is ASCII code conversion. This is also given by the Pico CTF team. So for those who are not familiar with ASCII code, it's basically how computer use 1 and 0 to represent an English letter like A, B, and C. So because our target audience is basically beginners, so we're thinking we will make it easier. So they only need to convert between decimal number and English letter. So every evidence in this scene will be encoded in ASCII, and they will need to decode it themselves to figure out the clues. But of course, for their convenience, we provide them an ASCII code book. And once they collect it, it will be added to the inventory system, and they can refer to it anytime to decode anything they want. So that's it for the game. But when we finished the game, we did a few playtests, and one thing we found out is that players love to click on this bird head statue, although we did not add anything to it. There's no evidence related to it, so it's not interactable. It's pretty disappointing, I would say, to the players because they really want to click it. So we're thinking, is there any way that we can change it? We can make it interactable, but we do not need to change out the whole game flow. So the solution would be we added an Easter egg to it. So when you click on it a few times, it's not gonna nothing will happen. It will just tell you nothing happens, nothing happens. But when you click enough times, like say 5 times, he'll be annoyed. And then it'll split out a hint like this, like paper to fire to book, just a general hint to tell you how to solve this game. So finish this game is not done for us because we need to make sure it can run on some low-end devices. So the hardware requirement given by the Pico CTF team is a Chromebook. So we went to Steve and asked him for the worst Chromebook he can get in ETC, and we tested on that Chromebook, and it just runs perfectly. And next, I will hand it to Josh to talk about the next minigame.
Thank you, Oscar. So in our second minigame, which is the cookie creature experience, the gist of the game is to make cookies and feed the creatures with the cookies you make. The player will be here to figure out the hatching rules, aka the recipes of the cookies. The game introduces the players the idea of hashing as well as the command line tool interface. So talking about the metaphors, the player would choose the operation of the machine, then drops into the machine the ingredients. The machine will then start producing cookies. For example, if the monster that you see here, he wants the cookie recipe worship, the player needs to put worm into the machine first and then the cherry in order to produce the right cookie. However, if the monster wants instead churro, the player needs to drop in the cherry first and then the worm. And that is the hashing rule that we want the player to figure out along the way playing this game, which is combining first 3 letters of each ingredient and form the name of the recipe. And you might be asking why we're using this interface. So the purpose of using this interface is that this is the metaphor for the real-life command line tool interface. The first column you see is the operations of the machine that the machine can do, and it's basically the command. And the second and third columns are the ingredients that you can put into the machine, which kind of is like the real-life options you type in. So the purpose of choosing this interface is to help the audience understand the basic logic of real-life command line to interface. So next, I'm going to hand it to Tianning to talk about the UI/UX solutions that we came out with.
Thank you. So here are some more questions raised up from our playtest and how we iterated on our game to solve them. So the first question would be, what should I interact with in the first game? So as you can see, the room is quite big and there are a lot of stuff inside this room. So that's why we make all the important objects in light color in contrast to the dark background of the room, so players can know what to interact with instead of telling them when to go where exactly. And also, we're using this hover state to let the mouse hover on the object and you can change color to encourage the player and give them the confidence to go next. And the second question would be how to make the in-game deciphering more smoother. That's why we came up with this deciphering table that can be put out from the side of the screen, that the players can always take it as a reference while looking at the code that they need to decode on. And the next question would be how to operate the cooking machine in the second game. So we have this interface that have 3 columns. On the first column, there's different actions that player can choose from that mimic the real-life commanding tool. So when player choose prepare in the first column, the second and third columns would be the gradients that they can choose from. And when they proceed to baking process, they cannot change that anymore because these interfaces are locked, and they can only bake the gradients they have already put in the cooking machine, so that creates less confusion. And when the player needs to get the food prepared and cooked, and they can transfer the food into certain destinations that they can choose from. So using the different status and different phases of the interface, we want to make the message quite explicit, and players can have less confusion interacting with the interface. And the final question would be, how do I know if the recipes are correct when doing this game? So we made different feedbacks as the monster's expressions to let the players know what they are doing. So the monster would be waiting for their food, and they will look confused when they get the wrong food delivered. And they will be angry if the waiting time is too long. And also, they will start eating if the players successfully deliver them the right food. So by doing that, we give the players the chance to look at the feedback and learn by doing. Then I'm going to pass to Josh.
So these are what left for us to do for the rest of the semester. We still have minigame 3 and minigame 4 to make. In minigame 3, we're going to introduce the idea of assignment and comparator, which is the equal sign and the double equal sign in programming syntax. And then in minigame 4, we're going to be teaching them the while, the for loop. And then when we're done with all those minigames, we're going to wrap them all up in this cyber magic school theme. And one thing to remember for the rest of the semester is that we are not teaching any solid kind of actual programming skills. We're nudging the players to try the actual Pico CTF questions. And that is everything for our presentation. Thank you. And we are now open to questions.
So are you logging player actions so you can share with the client, so you know which players went through all your activities, and then they can follow up to see, did those players that did all of your stuff go deeper in the Pico CTF competition? Are you sharing any logging information with players?
Thank you for the question. Sorry, let me just go back to this physics slide. So the question is, are we logging activities of players and sharing them with Pico CTF, our client, Scilab, so that they can check and compare with their internal statistics to see how effective our game is? And so that is obviously something that we do intend eventually, is a pretty advanced part. We do have an idea for making the scoreboard, so players will get score from doing different activities. So this is like the first step where players will just get more points for doing different things. So the more points they have will mean that they have done more things. So, and they'll be weighted, like more points will be given to people who do the actual Pico CTF questions. So they'll be able to tell how much they've, or in their own point system, how much they care about stuff. We can give different points to that. But eventually, yes, we would like to log more things in finer detail.
I guess related to that, what does your client want this to achieve for the overall competition? Do you have a sense of that? And if you do, how are you using that to make decisions, especially for the rest of the semester?
Thank you for the question. The question is, what is our clients like? What do they want to achieve with this, and how are we using that to influence how we're doing the rest of the semester? Do you want to answer that, or should I? Okay, I can answer that. So overall, final goal, client wants people to do the Pico CTF question. So they want to complete the all 14 questions from the mini Pico CTF. And then that's where our game will end. But ideally, the client would want these people to continue on in cybersecurity and continue going into the main Pico CTF competition, complete more questions there. And overarching goal is more people are interested in cybersecurity. So we are trying to motivate players to try new things and get more knowledgeable about cybersecurity to lead into that goal. So here we have a scoring system. Players will want to improve their score. So they'll try all of these activities, and then in doing so, they'll learn more about cybersecurity as well. And if anyone wants to add on that? Tianning?
Yeah, and just to add on that, our clients will be able to check how many people signed up for the pre-con activities and how many get into the competition. So that's also the goal we are trying to achieve.
Yes.
I'm wondering why the client wanted to be on the Chromebook specifically.
laptop device instead of a mobile phone. Did he share that information?
Yeah, I will answer that because
Thank you for the question. The
Thank you for the
question was,
question.
why is the minimum, why is the minimum device a Chromebook and not something more common like a mobile device? And Oscar has an answer for that.
yeah, and because the main competition or the competitions the Pico CTF is hosting is on a website. So basically, when the players go to move on and do their own Pico CTF team's competition, is going to be on a browser. And we're going to embed, as we show in the slide, it's like a WebGL build integrated in the browser. So we want to make it consistent, and because for Pico CTF, even without our game, the requirement is like a minimum Chromebook, so we just make it consistent with it.
And also, if it can run on the Chromebook, it can run on anything. It's lowest spec.
To add on to that, because it's like a cybersecurity competition, a lot of what people will be doing in the competition will involve like command line interface or stuff like this. So they'll require a keyboard most likely. So with mobile, it's a bit hard to do everything using the touchscreen.
Can I have a follow-up?
Yes. Thank you for the question.
So is there any minimum network requirements? Since I'm understanding that this is like an online thing, and people are connecting from a different platform to different browsers, and sometimes with WebGL games, they can be really big, and it takes forever to load. I'm wondering if you guys consider it or not.
Thank you for the question. Yes, we did consider that. That's why our game is mainly basically 2D sprite. So the load time is actually pretty small, and currently up on the build, the whole game is like around 20 megabytes for total. So that's for the whole game. So for the art asset, it should not be a long time. So we do expect the player will have like a low quality network.
Thank you.
All right, that's time. Thanks,
Thank
team.
you.
Hello? Hello, everyone. We are Team Impression. We'll introduce our team first. I'm Lauren, co-producer and in charge of playtesting.
I'm Hui. I'm the UI UX designer and the co-producer.
Hello, I'm Thomas. I'm the programmer.
I'm Ray. I'm in charge of design and documentation.
Cool. And our instructors are Heather Kelly and Ricardo Washington. So our project is about VR art therapy. And to give you a little bit of background on that first, in other types of therapy, usually you start off with talking about something, like verbal communication, and you use that as a starting point to get into deeper discussion. So in art therapy, instead, you would use art. The therapist provides an art space and art tools, and usually a prompt or an exercise to get you started. And this can happen in an individual or group session. Although group sessions are particularly important in this field, so our project is focusing in on that. Ultimately, the goal is to help patients unlock and express their thoughts and feelings in ways that aren't always possible with just talking. So there are a couple limitations in the current art therapy practices that we're hoping to address. One is that remote art therapy is very difficult because you lose out on body language, which is very important for a therapist to observe as someone is making art. And it's really difficult to do group art therapy because online dynamics are very chaotic and hard to manage. In addition to that, even if you're in person, you are limited by the art mediums you can use. You have to think about what's actually practical for a therapist to physically bring into a space and for everyone to clean up in a reasonable amount of time. The same goes for the physical environment. You want something that's comforting and creatively inspiring, but you are limited by reality. So the point is there's a lot of things you can do to help someone express themselves that you can't always do in reality. So virtual reality gives us a lot of solutions to that. One major win is that in multiplayer VR, you can have that embodied presence. So now you have access to body language, and group dynamics are a little bit less weird. So this is why we're focusing on using the Oculus Quest 2 as our platform. It's completely wireless, and it handles networking pretty well. So for art mediums and environments, we don't have to worry about any of those practical considerations. The only thing is for the art medium, we just have to make sure it's intuitive. So it's about as good as a traditional art tool. And the added benefit for the environment is that you can customize it in between sessions, or you have the potential to. That's our plan. This way you can tailor a session a little bit more to each client. So it's important for us to hit all of these things because our goal is to build a foundation for future inquiry by other people picking up this project, as opposed to a product with a lot of features. So we'll be working towards prototype and documentation. And we'll be handing that off to Tom Smith, who is an ETC alum and a current art therapy grad student at NYU. He's the one who brought this project to the ETC. And his advisor is Ikuku Acosta, who is a licensed art therapist and a professor in that program. So they're providing expert guidance and helping us shape the direction of this project. So now I'll let Harry talk about some of the work we've been doing.
All right. Thank you, Lauren. So after the discussion with our client, we aim to create an art studio for the VR therapeutic section. And like we mentioned before, we wish it to be relaxing, comforting, inspiring, and also prove to be efficient for therapists to use and not intimidating, so that the therapist can work the section proceeded with max efficiency, and also the client won't feel the pressure over the shoulder while in this VR environment. So what do? So besides setting a normal art studio usually do, we decide also to give more natural light input by putting over many window glasses. So here's the point, because we're in VR, so we can basically let the therapist to manipulate, to have control over the environment, not just inside the art studio, but also the environment outside. Based on the research we have, the environment outside also has some kind of reinforcement, can also reinforce the mood influence over the therapeutic section. So if therapists in VR have the control over the weather outside, they can basically utilize the weather not as things to hamper their therapeutic section, but use it as a tool to assist them to adjust it based on their preference. And also for the avatar, we decide to go for more neutral and simple approach, geometry shape approach, because we want the avatar to just be a means of communication, the movement to enhance the connection between the user, but also give user just the basic information about what other user trying to do, if they want to paint, if they want to interact, if they're waving at you, if they're looking at you, without causing distraction. So the therapist can proceed the section just by observing their movement without any distraction on their more realistic feature on the avatar. And also the client, the patient, the user can explore their art, create their artwork without getting over distracted and feel pressure if they feel like there's a real people near the site to intimidate them. Next, I will give to Hui to talk about the user interface experience and flow.
Thank you, Harry. So next, let me to introduce our interactive process of the project. So first of all, our target users are divided into two types, the clients and the art therapist. So for the clients, sometimes it's only one person and sometimes it's a group of people. And usually the art therapy session always takes only 1 hour. So lots of clients, they want to spend more time to making art and listening to the therapist analysis. So below that, we make the client's interactive flow. So after the client open the project, they will check in and enter the scene and communicate with the therapist and then make art. So for the therapist, the color is too light. After we talk with our end user, Tom Smith, we realized the first thing he needs is a virtual office that is a safe and comfortable environment. So in order to enhance the comfort and the security, we add two functions. One is the adjustable weather outside the window. Another one is background music. And we also consider the therapist may need a waiting room to ensure their psychological counseling process can be carried out completely in case some clients arrive early. So, and after an important thing here is the art method choice. For example, the painting, sculpture, sentry, and other things. But after we talk with Tom, we realized the painting is the most way he usually to use. So that's why we begin from the painting to make, yeah. And for this part, the therapist need to control the page size, the number of colors, and the canvas background. And then they need to be able to observe the client. Yeah. So next. So below that flowchart, we make our UI part. This is for the client part. So as we mentioned earlier, we want the client enter the art therapy session as soon as possible. So after the client clicks the project, there will be only two buttons here. One is the watch the video about our project. Another one is start the art therapy session. After that, they will check in here and start now. And they will note here is the Tom Smith's virtual office, and please wait a few moments, he will be logged in. So for this part, when the client are ready to paint, there will be a color palette and the brushes floating on client's hands, and they can use both hands to drawing. So for the therapist part, because therapists can always use the VR device, so we put all function keys on the therapist UI. After they open that project, they can check the calendar first, or maybe start the session anytime, and they can adjust the weather here. We provide those weather functions for the therapist and then enter the main menu. Yeah, for the main menu, here is the weather, here is the weather choice, and here is the background choice. And for here, we have three buttons, quick start the session, end the session, and one click to remove the canvas. And if they click the background music, we provide 4 kinds of music here. And we also have the setting button. it's just convenient for the therapist to adjust the client microphone's volume, because some client maybe feel confusion how to adjust the microphone's volume. Yeah, and then the last thing is the method choice. So if they click the painting, they will have the access to choose the page size, and and they can start the session anytime. And we have the color choices and the canvas backgrounds, and then they can start the session. Yeah. So when the client is painting, the therapist UI will look like this. We designed a watch for the therapist, hope to give him some convenience to control. And there are 3 buttons. For the I one, it means the observation mode. So when the therapist click that, he will disappear from the client's eyes. And for this button, it's move button. So when the therapist click that, he can adjust the client's position during the group session. And the last one is the main menu. Yeah. So next, let's welcome Thomas to show our prototype.
All right, I'm going to show you the prototype. Fingers crossed. Here. Take this. Is it showing? Just a moment. Yeah. All right. It's good enough. So here we have our app. If we have the email of users, they can download it remotely after we add them. So we can do remote play tests without ever meeting them, like without going to where they are. And I'll just open it up now. Just a moment, sorry. So this is our virtual environment. I'm a little bit in the ground. My bad, it's a problem with the Guardian, but and then we have a drawing experience. So you take a brush and you just draw on the canvas, and you can see that the thickness varies depending on how much I put the brush into the canvas. And then this is a multiplayer experience. So this is Lauren. Lauren, say hi. Yeah. And then, all right, I don't know if Hui is here yet. Oh.
Yeah, I'm here.
All right. Hui, say hi. Yeah. And as you can see, we can all see what everyone else is drawing, and we can draw collaboratively if it's a group session. So we've tested this out with Tom, our client, remotely, and it works perfectly. So we're all set to do remote play tests in multiplayer. So this is our prototype for the moment. Now we're going to talk about play testing. Sorry.
Okay, cool. So to wrap up, we'll just briefly touch on play testing. Since we want this tool to be intuitive and usable, we are going to test it with some people. So we're distinguishing between testing the functional use of it and the therapeutic use. So functional use is how well does it draw. Therapeutic use is using it in context, sort of. For that, we'll be working with our NYU people to make sure we work through the processes of art therapy without getting too deeply into the complications. So far we've been doing functional playtests, and we're going to move into therapeutic sessions and sort of focusing more on group functional playtests going forward. And in summary, we're going to build a multiplayer VR experience that includes an art medium and a comforting and inspiring environment. And all of this is going to be very playtest driven, both with ETC students and local art therapists like contexts. And we're now open for questions.
Yes.
it seems like there's a lot of scope to do both painting and sculpture. Can you talk about the motivating factors to include both?
So the question was, it seems like there's a lot of scope to do both painting and sculpture. So what factors, why are we including both?
We're not including both. Thank you. I don't know what slide gave that idea, but we're not.
So there, I think in the UX UI, you can choose between painting and sculpture.
That may have been just a small.
Okay, so why did we go with painting?
Why did we go? So painting was the first thing the client asked for. They said, if we can do nothing else, we should do painting. We're not necessarily making, a VR. We're not making the best VR art app. We're making a VR app that's usable for art therapy. So creating the coolest art mechanic is not necessarily the point, and we want to be able to dedicate time to testing the interaction of testing mock sessions and polishing that experience without spending too much more time on an advanced mechanic, let's say. Yes, thank you. Chris was first, yeah.
So, I guess, can you investigate the potential discomfort with using VR as a medium and its effect on the therapy setting?
So the question was, did we investigate the discomfort someone might have with VR? I think, part of the playtesting is to make sure that we don't make anything uncomfortable in VR, but as for whether or not somebody being in VR to begin with is going to be uncomfortable, we've kind of taken that as a limitation of our demographic that we're sort of not addressing in this project.
Yeah, to some degree, we all know that there is discomfort in VR, that maybe that's insurmountable. I don't think these are super long sessions. It shouldn't go over 45 minutes to an hour.
And in that, not the whole thing will be in VR.
Yeah.
So who chose VR?
That was the project description, and the client was on the same page. They knew that they wanted VR. Yeah.
So how long will the time in VR be for the patients?
I guess that depends. We're kind of still working that out with our NYU people. I think once we get into the therapeutic playtests, they'll have a better idea of that. So far, we've been playtesting with people for 15 to 20 minutes, and nobody seems to be having problems for that period of time at least.
So half a semester in, what would you say the major win of art therapy in VR is? What does VR present as an opportunity for art therapy?
So the question was, what is the major win so far for having VR in art therapy VR?
We have a tool for remote art therapy. That's actually one of the first priorities for our client, is being able to do remote.
Have one more?
Wow.
So you asked one of the key benefits of VR is that you get body movement, body. I'm wondering how you can get it if VR just gives you two hands that you can monitor and it's really controlled. It's not like you feel natural control software now.
So the question is, how are we showing body language in VR?
So I think that the gist of that was that in VR you can get, for remote therapy, in VR you can see more movement than on Zoom. So keep that in mind, and then the hand movement and head movement are improvements in terms of body language. We're not planning to create some kind of machine learning rig or something that shows your full body movement. But yeah, it was with respect to Zoom, it's improved.
All right, thanks, team.
Thank you.
Want to stand there?
Okay. Hello, everyone. We are Team Molten Core. We are working with Rivers of Steel as our client to create an AR enhancement for their tour of the Cary blast furnaces down the river. So for us as a team, I'm David. I'm the producer.
I'm Tianyi. I'm the narrative designer and sound designer on the team.
I'm Eric, another programmer.
I'm Shuxin, the other programmer.
And I'm Shinu, and I'm the artist.
And for our advisors, we have Scott and Mo. So as I said before, our client is Rivers of Steel. So they are a heritage foundation devoted to preserving Pittsburgh cultural heritage, mainly around bridges and the steel industry and those sorts of features of Pittsburgh. So for us specifically, we'll be focusing on the tour of the Cary blast furnaces, which is involved in the purification of iron for steel production.
So in terms of what we are building, we are trying to create AR effects to empower the tour guides to better deliver the tour to the tourists. And as you can see, we want to create a phone app for the guests, and we want the tour guide to have a kind of control app for the actual effects to happen. And then we want to build an authentic and historically accurate experience. So during the tour, we've been on site twice, more than twice, but like before we started to create the project, we've been there twice, and we've been there once with the client and once for an actual tour. We interviewed several tourists and also the tour guides and choose 3 major locations we want to focus the most on. The first one is this car dumper location, which is a very cool stuff to dumping all the iron ore out from the car. And the second is the cast house, where the flowing lava of iron just flows through these troughs. And the third one is kind of the reaching goal for us, which is the stove deck. So our project goals is we are designing for the kind of average tour guides. So most of them are about 30 to 60 years old, so children are not that common, although there are several school tours. And most of the tour guides who visit the site will have some personal relationships with the steel industry. So we want to solve the problem for the explanation lost between the tour guide and tourists. Because like tour guides can just tell the stories through words and with still images. We want to use AR to enhance that. So our goal is to make sense of the tour guide's walkthrough.
So the reality of AR that we're dealing with is that the technology is still very new. So for our guests on the tour, we'll have to explain to them how to use it, as well as for our tour guides who will be controlling the entire experience. We also will need fiducial markers to position the users in the space. So we will have sort of markers throughout the space, similar to how current experiences use something like existing art in the space. We'll try to integrate our tags in the space as well as possible. And lastly, we have done research on how AR affects people's communication with each other. And what we found is that while it may seem like AR forces people into isolation in their own phone, it actually brings people together and gives them something to talk about. So it starts conversation between tour guests.
All right, so to help kind of like document and like visualize our vision, we created many scripts, like scripts that help like, that entail a lot of like what happens in the experience. what the tour guide would say and what we were planning to have our augmented animations to do. And then once we have our script, then we build a storyboard. And we created many storyboards, and this is our latest iteration. And I'm going to just kind of quickly go over what the storyboard's about. This one's about the cart dumper, and it begins with the tour guide asking all the guests to scan their fiducial marker and download the app. And if they don't have it, and then that's kind of like where they would start the experience. And at the second panel, it's them at the actual location, which is the cart dumper. There's another marker there, and then the tour guide will instruct the guests to scan that image target, so that way they can actually have that animation activated and ready to go. Once the tour guide presses the activates the animation using the master iPad, which they have. So once they press that button, then they can actually start the experience, and the tour guide has full control of the entire experience with a whole array of buttons that they can use. And they'll first press the train button, which will generate a virtual train that moves across the track. Train engine sounds will be generated, and it will be coming out of the user's phones. The cart stops at the correct position and makes sure that the cart of ore is positioned right in the middle of that cart dumper. And then the bottom three panels, this is where the tour guide will be talking about some really fun facts and talking about how heavy 100 tons of iron ore is in each car. So in that panel at the bottom left, it's going to be the tour guide's going to talk about there is 100 tons of iron ore in each car, and that's equivalent to the weight of 20 elephants. And the weight of 20 elephants is equivalent to the weight of 200,000 cans of Campbell's tomato soup. And then after that, then the cart just reappears. Next slide. Yeah. And then to also kind of just further just emphasize how hard life was before the cart dumper. It'll generate one animated worker just trying to shovel out the ore, just to kind of emphasize that before the cart dumper, all of that unloading had to be done manually. And then it's going to generate around 10 more workers, animated workers, and then that would say the tour guide would say even with a team of workers, it would take days or even hours or weeks just to unload one ore cart. And then finally, the tour guide will press the last button, which is the cart dumper animation itself. He presses that button. He'll probably will say good thing they had the cart dumper, and then the animation will play. And as it's playing, which can run multiple times depending on how the tour guide wants it, we'll probably explain how the cart dumper works. For instance, the metal arms that actually clamp onto the cart so that way it doesn't fall over. And then after that, finally, that part of the experience is over, and then they move on to the next one. So, yeah.
To integrate the virtual objects into the real world, the blue things into the real world, we need to create a AR marker. One possible choice is to use the QR code or APR tag, which is simple and robust, but we want to do better. We noticed that there are a lot of graffitis on the wall or painted on the structures, which actually was part of the culture, the heritage culture. We want to take the advantage of those artwork and make them as fiducial markers. However, we had a lot of challenges in the field work. The first challenge is the shadow. You can see the shadows on the picture. The shadow actually made the graffiti hard to be recognized by the AR core. And also, our clients raised the concern that those graffitis may decay with time. Also, if they are damaged accidentally, there's no way to replace them. And another problem is the on-site work condition. You can see the picture here. Because the place was supposed to be a factory, it used to be a factory, and there's no desk, no chair, or even no stable Wi-Fi connection. It's really cumbersome to work in Unity and adjust parameters on the spot. And here is our solution to tackle the issues. First, we will change the anchor to our client's logo. You see here, even with the shadow, the new marker works well. And we also created a calibration system which allows us to adjust the position and size of the virtual object you see here within the app without the need to rebuild the app repeatedly.
Another thing we try to tackle is that although we are creating this AR experience that runs on everybody's phone, we want people to see the same thing at the same time, which is why we created a network system that allows us to synchronize animations across multiple devices in real time. As you can see in the demo, we have the several buttons for the tour guide to click on, and each corresponds to one animation, and they all synchronizes in real time.
So now it's time to kind of like talk about like the art assets, and to kind of start off, here is our card. Here's actually the org card itself. We chose this one because this is our first 3D model, and also is a really good example of our art pipeline. We first model the model, and then we put it into Substance, and we texture it there.
So in order to position that car in the space, we went on site and took a 3D scan using LiDAR on an iPad. And so you can see on the right is the space itself, and on the left is our scan. So what that lets us do is then position the car in the scene on campus without having to go back and forth between the site.
Yeah, and using those scans, we use those, we import those into Maya, and then we build our 3D models off of those, so that way we can make sure that we get a one-to-one scale model and everything is proportional as it should be.
To tell the story, we created our shoveling man animation in the first. This is what the tourists will say when the tour guide play the, show the shoveling man out. So this is only one, but you can kind of imagine what it will look like when there's 10 or more. And after that, we have the car dumping animation with the 3D model. So the sound volume is a little low, but yeah, all sound effects are also added to them.
So for our second scene, we're looking at the cast house. So again, we have a picture of the cast house on the right and the scan on the left. So because we have this scan and this mesh in Maya, what we can then do is simulate iron pouring through the trough in Unity.
On the screen, you can see a small workflow test that we did with the full simulation importing into Unity. You can see the red hot molten iron flowing across and dropping down onto the plane below. With that, we could, by doing this, by baking the simulations into models, we can run it in real time on a smartphone without needing to worry about the performance problems.
And for a stretch goal, we'll be looking at the stove deck. So here is a place on the site where the workers were in especially a lot of danger with regards to carbon monoxide. So we're looking into having workers interacting with each other and showing the dangers in a sort of visual way, as opposed to carbon monoxide, which is an invisible killer. So our next steps for the project is to put it all together. So right now, in our first experience, we have all of our stuff in parts right now. So we'll need to put that together and have it all be able to be triggered by the tour guide. And start work on our next scene. So we have the fluid simulation working, but we'll need to script out the entire scene and add a few more effects in there to fill out the experience. And as for our stretch goal, again, the stove deck, which will require more human animations, which are particularly difficult. And that's it for our project. Any questions? Yep.
So a real important piece about that cast house is separating out the slag foam from the iron underneath. Are you gonna do some of that, represent the slag in some way?
So we're not really looking into the slag itself. We want to focus on the most impactful parts of the experience, and we feel like the iron pouring and the bright effect here is very enticing for guests to get them into the mood of the scene. And we feel like this is at least on the site where we see before, if I can go back. So the slag in this scene sort of pours out in a different area than these troughs. So we want to keep it central around this area.
Yeah, the tour guide, so I just saw the tour Saturday.
Mhm.
They talked about the slag is gonna be the main straight line. The bright
Mhm.
iron is gonna be the wide piece coming towards us. I just don't know if it's gonna be bright all the way up to the furnace.
Mhm.
It might not be. It might only be bright at the bottom.
Mhm. Yeah, once we move on to our second scene, we'll definitely do more research on all of that stuff moving forward.
Dave?
Yep.
It seems like one of the weaker links is your tour guides and how they're going to be able to, like, they're not going to be the same people. They're going to have to be trained all the time to run this. And if they get out of the field and they try to run it and it's not working, what's the backup?
So we're working on making our UI very intuitive. And as for our deliverable, we'll also be training at least one tour guide on how to use the app so that we can then, so they can transfer to all the other tour guides as they hire more, have more people need to learn how to use it. As for a backup, we are considering having the effects run locally on the tour guide's iPad so that they won't have to trigger it for everyone else. They can sort of just show it off on their own iPad, and it'll all run locally so they won't have to coordinate everything. Dave?
I guess to that end, are you planning on playtesting with tour guides and real guests? It sounds like especially with the storyboard you showed, a really good interaction between the tour and the effects, and you talked about the guests having conversations. Do you have plans to look for that and then iterate that in this semester?
Yeah, so I think Tianyi mentioned it earlier. We went on a tour at the beginning of the semester with other actual tourists and spoke to the tour guides and the tourists on what they would like to see, and they all seemed very excited. So we think that in the future, we'll be able to playtest using actual tourists to see what they think about our experience and what to add and change and those sorts of things. But it sounds like people are looking forward to this. So as soon as we can get what we have into their hands, the better. Mm-hmm.
Jesse emailed me a question. He's watching on YouTube. He wants to know, does everybody in the tour group need AR, or does it work if just some people have it?
So this works with as many people as want to use it. So we found that on some experiences we looked into, the guests were sort of sharing phones. So if people came in groups of 2 or 3 or as a family, they'd all gather around one phone to watch it together. this can work on as few or as many devices. Again, our backup is just the tour guide showing people on the iPad. So in that case, no one would have to have a device for everyone to see it. But we do want as many people to have their own device as possible so that they can experience it themselves.
That's time. Thanks, team.
Thank you.
Thank you.
Hello, we are Team Ideal. Yeah, I got it. Hello, we are Team Ideal, and this is our team. No. Oh, I'm sorry. Bob, fix it.
This button goes forward.
All right, yeah. This is our team. Our project instructors are Shirley and Mike. Our clients are Putrino Lab that operates out of the Abilities Research Center at Mount Sinai Hospital and Carnegie Mellon University. Our project is about creating a fun game that uses an eye tracker and a click and trains people to use the eye tracking interface. Our client requires us to build a game which is fun, utilizes an eye tracker, a click, and trains the guests to use the eye tracker and also provides analytics to the researchers. Our deliverable will be a game for the PC that uses the Tobii eye tracker and provides analytics. Our demographic includes 15 years and older people who are neurologically injured. The goals of our project are to have a game which has low barrier of entry. It is simple to pick up and hard to master. The guest wants to keep playing. Then there is mastery over skills, and you can also track the level of success. And now I will invite Ryan to talk about our production process.
Thank you, Anjali. So first, we are building one game for the eye tracker, but first let's talk about what we've done so far. So first, we start off by asking our clients what their needs were for the eye tracker device. And so we got to them, and they were very explicit about their needs, which were this needs to be a fun game for the eye tracker and a click that would ideally train people how to use the interface and, if possible, get metrics and data so that we can track their improvement. From there, we are able to think about what are other needs and what are other restrictions of the eye tracker, and we use that to think about what would be a good experience for the eye tracker. We also asked our clients what were similar products in the industry, and they told us that AimLab was the most similar product that exists and AimLab is a program that trains people to improve their FPS skills. From there, we did a brain dump of our different ideas, of prompts that we thought we could be well suited to an eye tracker. So we brain dumped about 80 ideas, and then we grouped them. We ranked them based on our own interests, as well as how well suited and aligned we thought they were. And we brought these and tried to iterate them and solidify these ideas in whatever way possible. At the end of week 2, we brought our top ideas to our clients, which they got back to us, and for each idea, they noted what was the most interesting about it and what kind of directions they wanted to see us explore. From there, we divided our team and explored with multiple different prototypes. Here we have 6 different prototypes, which we built throughout the courses of week 2 and week 3. Here we are trying to identify primarily which interactions feel the best with gaze, and we showed these at quarters and on end of week 3, to which our client was able to point out which demos had the most potential in their intents and uses. From there, we limited our scope down to 2 or 3 demos that were the most promising. We tried to investigate what were the most critical questions and concerns with using the eye tracker as an input device, and so we targeted our future developments to answer those questions. In those developments, we also found other new avenues which we pursued for different variations and to try out new things. By the end of week 5, we were able to run a playtest with people from the EDC, so we had about 14 playtesters to come and try our 3 prototypes. From there, we had to identify and collect our findings and determine what really felt good and what did we learn in these 5 weeks of pre-production. And that question is so important that I'll hand it off to Ray to talk about it.
Thank you, Ray. And I'll talk about the design iteration. How we derived from the 3 prototypes to our game is called the Spaceboat Nova. And then the first one is a spaceship. Could you play the video for me, please? Oh, there you go, I got it, thank you. So in this game, the players plays a pilot in a spaceship, and they use the gaze cursor to the edge of the screen to tell the angle of the camera, and they also will dwell on the enemies to make a shoot. And what people like about this prototype is the freedom of exploration in a wide range of 3D space area. And they also like to track the movement of the enemy. They like to chase it, like a spaceship chasing another one. And also, we find that this fantasy, the spaceship, widely appeal to a wide range of population. What people don't like about this is the confusion about enemies and targets, because people will get lost in this kind of very open area too. And also, it causes the disorientation. And then we have the next prototype is the hero ball. In this prototype, the players will play as a ball, and they will gaze on the enemies to charge towards them and fling them away. And all these bad guys will try to approach an objective that the players need to protect. And once they hit into a boss fight, then there will be a mini game that the players need to dwell on the weak spots of the boss, and then they can fling the boss away. And what people like about this game is they think the flinging is so awesome. They like to do it. And also, they like the minigame dueling on weak spots too. What people don't like about it is like making sharp turning with the eye trackers is really like a torture. And also, people will get lost with where the objective is. And then, the third prototype is actually a variant derived from the hero ball. It's called the endless running ball. In this one, the players, there's no need to make sharp turns anymore. They're just moving forward and tilting their angles to aim at different enemies, also by gazing on them too. And also, they'll try to avoid getting hit by the yellow obstacles on the way. And what people like about it is the rewarding combos. They think flinging these little guys one by one is so awesome. And also, people feel excited about it because it's fast-paced, and the mechanic is really replayable. What people don't like about it is this mechanic is easy to get people tired, also because it's fast-paced. So we try to keep all the good points of our games and try to throw away all the bad points. We forge them into our game. It's called Spaceboat Nova. The players is going to be like this little spaceship on the right, and it also has a weapon as the momentum horns. The horns are the horns of the bull, and we'll get to that later. So the mechanic of this game is a spaceship chasing game. That the players will try to gaze on the enemy's movements, and once the cursor is overlapping the enemy, our spaceship will speed up to chase them. Otherwise, the speed goes down. And of course, the enemy will dodge away from our gaze. And what the players need to do is to do a smooth eye tracking with the movement of the enemy to keep chasing it. And on the way, there will be some obstacles as asteroids, and sometimes even the enemies will dodge behind these asteroids. So there will be two options left for players. One is to get close enough to the obstacles and fling the asteroid away with their horns, or they just look at the edge of the screen to dodge it. And we also keep the mini game. And for this time, it will be like the enemy is trying to attack the player by shooting some missiles flying towards them. And then the player will automatically enter a shooting mode. Then the eye cursor no longer tell the angle of the camera, but instead it will scan and lock on these missiles. And they can use the click function to shoot them down. And then finally, we got super close enough to our enemies. And our horns are ready. When you start click to fling them away and deal damage. And for the overall structure of the game, because we know that this kind of fast-paced game is really tiring, so we're also going to start the game with some slow-paced exploration for collecting some buffs or equipments or telling stories. And then we encounter a chase fight, and then another exploration. And for that, and we have a demo of the chasing mechanic so far, and we'd like to invite you to enjoy it a little bit. And there's a little red guy, it's the enemy, and the player is trying to keep the gaze on it. And the bar is actually the distance to fling. So when we're chasing the enemy, the distance to fling is getting shorter and shorter. And we're approaching it, ready to fling, but we don't have it yet. So okay, I'll pass it to Bob to talk about the data analytic.
So the main point of this is that the client wants to get analytics to make sure that the user's improving, that the patients are getting better. And the 4 key metrics that they wanted was accuracy, precision, reaction time, and smooth tracking. And the first place that we wanted to go for was accuracy, since we thought that might be the easiest to get. Our first thought was, there's a bunch of objects, let's see how many objects they can get out of total. And another thing that we thought about, maybe if how much time they're looking at the object versus how much they're looking in general. But our client said, like, no, they want to see how close they can actually get to the center of an object, and basically how close you are to a centroid. And from that, they were going to ask like other questions, like what is their vertical offset from that centroid? What is their horizontal offset? And another thing they want to know, like how close is that distance? And also, like, does their accuracy actually improve if the asteroid is bigger or smaller? And another thing we wanted to go on was precision. So we thought precision, can they get to the same point multiple times? And the client said, like, no, that's not what they want. They want them to know how clustered these attempts are, how close they are, what's the deviation between all of these. And they're trying to see, like, how close you can get to what's itself, like where they're attempting and how close they can be. Another thing they wanted was reaction time, but they made it a point that there's 2 factors on reaction time. One is how fast can they get to that object, and how fast can they click on it. The second one's important because they wanted metrics on how good their click system is. What's the response time for that? And the last thing they want was smooth tracking. Can they get from point A to point B and probably follow a shape on screen? And with all of this analytics, everything's going to be exported to an easily readable CSV, which is really good for our researchers since they know how to measure data. And I'm going to give it now for Ariana for art.
Thanks, Bob. So for the art, our main design goal is to reduce visual distractions and enhance eye tracking experience. Based on the 3 game art references, we want our game world to have, first, a clean and straightforward environment. Second, fewer colors with proper contrast. And last but not least, a large space for players to explore. All right, so we decided to move on with the space theme. And this is the concept art we have for the game world. So for the player spaceship, which is called Spaceboat Nova, it has 2 firing modes. First, it can use a pair of horns to knock away enemies and obstacles at close range. And second, it can use turrets to shoot at targets at long range. For enemy spaceship, which is called Killer Whale, it is colored in red and can fire homing missiles. All right, for other non-major game assets,
I designed a pipeline to create them procedurally. So I kind of use Houdini to generate the meshes and use Substance Painter to generate the materials. In this way, I can quickly change the color, size, and shape of the assets in a non-destructive and efficient way. And finally, for the UI, we want the UI to be simple and clean so that it is easy for players to understand and fast to respond. We also want to have minimum and readable text. So these are the UI elements we have for now. This is the circle cursor for eye tracker, and this is the progress bar. Next, I will hand it to Leo to talk about the schedule.
Thank you, Erna. So yeah, let's talk about the schedule, plan, and our future. So we've gone through our ideas, our explorations, and our decisions in week 1 to 5. Let's talk about week 6 to 15. First, we're going to divide them into sprints to develop and update our game and play test with our clients, consultant, and the surrogate playtester. Eventually, we're going to have a playtest with our demographics on week 10. And after that, we're going to iterating, polishing, and debugging. And in the end of the semester, we're going to have a documentation and hand off to our client. We express special thanks to our playtester and faculty that helped us. And we're now open to questions.
Oh. Questions? Oh, I see Mo.
Was there any work to learning the improvement of your trackable metrics on your prototypes?
Okay, so the question is, was there any progress on improving the metrics on our prototypes? And the answer to that is no.
Well,
Maybe
to
there was.
degree, yes. For the mini game for the Hero Bowl, where the horns were stuck on the shield, there's that one mini game where you had to look at the 4 corners. And then while Leo was programming that mini game, Bob was actually working on the CSV export, such that in a very similar scene, that if you look at the corners, it would record the metric of how long it would take to have those corners disappear. Unfortunately, like we had our conversation with our clients about the improvement of the metrics and the actual definition accuracy. So the accuracy tracking that's implemented with that specific prototype isn't exactly what our client wanted, but we do have the experience of taking those instances of gameplay and turning those into CSVs, if that's what you're asking about. All right, Dave?
I guess, based on what your client's looking for, why do you think your prototype will work?
So the question is, based on what the client is asking for, why would our prototype work? The answer is that our client primarily wants a game that is fun for a wide range of demographics. And the reason why we think that will work is because it was based off our playtest findings. So if we go to the slide after this, we actually asked a lot of our playtesters about how they felt about all of our prototypes, whether it made them excited, neutral, or excited. And we saw that the spaceship actually had, was the most consistent amongst all demographics. What's not pictured here is the correlation between the playtesters and other factors such as age and gender. But the spaceship had the widest range of appeal for a number of reasons, because of the theming, also because it had just a generally better interest curve. And for that reason, we're taking a lot of those lessons and incorporating them into our final design, which is Spaceable Nova. Does that answer your question? Cool, thank you. The question is how many people have playtested these? I think we got 14 playtesters, 13 students and 1 faculty. Thank you, Ricardo.
Yes.
Oh, Lewis?
In your timeline, you have 2 week sprints, 1 week sprints, and iteration. Can you talk a bit about the differences between those?
Yeah.
All right, the question was, can we talk a little bit about the differences between our sprints?
So as you can see in sprint 1, we're actually building the game, but then during during week 8, we're actually play testing as we're doing the sprint. So so we're actually play testing and then doing fixes along with it. And then during sprint 3 is actually when we play test with the client's constraints, and we're actually play testing with the demographic, which is supposedly people who are paralyzed.
Yeah, so it's the decision between sprints is mostly internal, as into our focus with development, whether we're focusing on overall gameplay or whether we're doing our tuning towards specific tendencies.
Time for one more.
Oh, maybe people are tired, I guess. Yeah.
Oh, Thomas?
That progress bar, the distance,
Oh, distance to fling. This guy.
it goes, the closer you get, the less it is.
Yeah, so the question is, the distance to fling, the closer it gets, the less it is.
Yes, and the answer to that is kind of like a temporary implementation. Actually, what we intend to do that is to change the word here a little bit more to make you feel like the closer you get, the more is in the bar. So it's actually like a progression bar. Once it's been filled, you finish the one chasing stage.
Yeah, and all our UI is subject to playtesting.
All right, thanks team, good job.
All right, thank you.
Thank you.
Okay, congratulations to all the teams who won today. You got through Halves and RPIS.